Hello everyone, I am Dr. Emre Süren. In this lecture, we are going to introduce you the tool that we are going to use, actually how to automate prompt injection and jailbreaking attacks. First, I will run my VSCode where we access our code base, our tool. As you remember, it is prompt injection playground. So we have utils and workspace folders here. We will always use workspace folder. As you remember from the previous lecture, here the workspace Jupyter notebook. In previous lecture, we run these two commands to initialize our workspace, as well as to list the capabilities of the tool that we are going to use. There are a couple of tools to perform prompt injection and jailbreaking attacks. The logic is different in these tools, so that's why I would like to introduce what is the mechanism, what is the logic behind this tool that we are going to use, which is Spikee. First, I would like to show you the data set that we have included in Spikee, which is under workspace. Once we initialize our workspace, we also automatically downloaded or copied these data sets into our folder. Let's see. In action, I run this command. It just listed the folders or data sets or payloads. On the left hand side, it is cybersec 2025-04, empty, harmful instructions only, and so on. These are our data sets that we will be primarily using during our experiments. Let's see what type of targets we have. You should remember from the fundamentals lecture where I told you two targets. We can target directly a large language model or an application that is powered by LLMs, LLM-powered applications. So here in targets, we are expecting to see LLMs primarily, and we also installed LLM webmail application. Let's list the targets our tool supports. It is taking a bit of time. So here we go. These are our targets. These are local targets: LLM mailbox, sample PDF request target, sample target legacy, simple test chatbot, test chatbot. Here we can find related Python code. Actually, these applications primarily perform an HTTP request to the application. Application should be installed separately. Now I will click this scrollable element to see full list of targets, and here we see the large language models like AWS Bedrock API, Azure, DeepSeek, Google. For example, once we select Google API, we can also select the exact model that we want to use, test, for example, Gemini 2.0 Flash. If we don't set anything except Google API, it defaults to Gemini 2.0 Flash. But if you would like to use something else, we should write it specifically. We have Grok, and here, as you can see, we have large language models, and also LLM guards. We can also test LLM guards. Ollama API, if you are running your own models on your local host, like me, like this Ollama, I have here DeepSeek, Gemma, Ollama, Qwen, and I guess I have GPT-X here. So you can run these models on your computer. I strongly suggest using Ollama if you don't have experience with APIs, because if you run unnecessary commands, every execution will cost to you. First, it is a good practice to learn in your local environment. Then you can try the models online, but you need to have a GPU to run these models. Try on your laptop first. If it doesn't work, then you can try open models. For Gemini, you can find a free API key that you can benefit. OpenAI, the default is GPT-4. And absolutely TogetherAI. TogetherAI provides you access to open models. For example, you would like to use Ollama, but if you would like to use Gemma from Google, Ollama is from Meta, Mixtral from a European Union organization, Qwen from Chinese model. So TogetherAI provides access to all these open models. If you are not able to run Ollama on your computer, you can use them from TogetherAI, and the cost of TogetherAI is relatively cheaper than pretty much all other options. For example, OpenAI, Grok, GPT, Azure, AWS, and so on. And what is good with TogetherAI, you can find models from different brands. But if you use OpenAI API, you will only find OpenAI model. Similarly, if you are purchasing API key from Google, you will only access to Gemini model. When it comes to TogetherAI API, you can use all open models. And this is what I'm using as well as with Ollama API. So now we will see next command, which is plugins. Let's run it. Here are our plugins. Actually, plugins transforms our payload into some other format that is a way to falsify large language models. You can pretty much consider it is encoding, obfuscation, and similar. As you may remember, this stands for lead code. Base 64, very common encoding algorithm, Caesar cheaper, X encoding, and so on. And we will see what is prompt decomposition, best of an attack, anti-spotlighting. These are plugins or encoding techniques special to prompt injection, large language model ecosystem. Then I will introduce you the attacks, the capabilities of attacks. So here we can develop our own attacks, which will be listed under local, or we can list the attacks. This is the sample attack Python, and these are the built-in attacks: anti-spotlighting, best of n, prompt decomposition, random suffix search, multi-turn, and Crescendo is relatively newer attacks, and we will see all of these attacks. These usually used to enhance default attacks, default payloads. So we are done with these commands. Then I'm going to run generate command. Spikee here is the tool. -Q stands for quiet, which prevents Spikee to print banner. And this is the generate command, generates dataset, and -H is the help. It will show us how generate command works. Okay, here are the parameters that generate command takes. For example, plugins that I introduced to you, and there is an option parameter also for the plugins to configure. Languages, for example, we can have multiple languages in our data sets, but if our target is English, so we may prefer using only English. Instruction filter, we can select the attacks that we would like to perform. Dataset generation is the first step. The second one is test. Here are list. We can define our target and we can show our dataset folder, payload folder. We can also set the speed of our attack. So in large language model testing, sometimes it takes a lot of time, and sometimes for various reasons you may need to stop your execution. Then you may want to resume your execution. So we have a switch for auto resume, but sometimes you will want to repeat your tests. So we have another switch for it also. The final command is analyze. So we generated our payload, we performed attack, and we need to analyze the results coming from the large language model or application under test to see our performance. Spikee results analyze. This is the switch that we are gonna run, and we will show a results folder where we will write our results. So for this lecture, that's all. See you in the lab 1. Thank you. I am Dr. Emre Süren.